Ladies and gentlemen, welcome to this episode of my tutorial video channel. In this video, I will discuss why two indifference curves cannot intersect each other. That is, one indifference curve cannot intersect another indifference curve. Indifference curve is defined as a locus of all the combinations of two commodities which give the consumer same level of satisfaction. That is, on a particular indifference curve, the consumer is indifferent among all the points on that indifference curve, and each point denoting a particular combination of two commodities X and Y. And here we are considering a two commodity scenario. Indifference curve is based on human rational behavior. It is assumed that the consumers would behave rationally, and one of the important rational behaviors of the consumer is that consumer prefers more to less. That means if the consumer is offered 8 units of A or 9 units of A, then consumer will certainly opt for this offer because 9 is greater than 8. This is rational consumer behavior, and the indifference curve technique of consumer's behavior and theory of demand. It is assumed that the consumer behaves rationally and the consumer prefers more to less. Now today's question is, why two indifference curves cannot intersect each other? Now I shall draw two indifference curves intersect each other. Then I will explain why they actually cannot. That is, I will draw two intersecting indifference curves. Then I will explain why this is self-contradictory. Right? So look at the whiteboard. The question is, why two indifference curves cannot intersect each other? Here we are drawing two indifference curves intersect each other. On x-axis we measure commodity X, and on y-axis we measure commodity Y. Suppose this is IC1 and this is IC2. Let these two indifference curves intersect at this point, which is, say, M. So M is the point of intersection between IC1 and IC2. Now consider these 2 points and these 2 points. Say this is point A, this is point B, this is point C, and this is point D. So A, M and C lie on IC2, and B, M and D lie on IC1. Okay. Now since B and M lie on the same indifference curve, so the consumer is indifferent between B and M. Let M denotes x1 of X and y1 of Y. B denotes x2 of X and y2 of Y. A denotes x3 of X and y2 of Y. Now the consumer is indifferent between A, M and C, why? M is the common point, therefore satisfaction from M is same identical to satisfaction from A, and again satisfaction from A, M is same as satisfaction from B, that is A is equal to A and M is equal to B. So this gives us the consumer is indifferent between A and B. From here we can conclude that the consumer is indifferent between A and B, because the consumer is indifferent between M and A, and the consumer is indifferent between M and B. So the consumer is indifferent between A and B. But you see, B denotes x2 of x and y2 of y, and A denotes x3 of x and y2 of y. So while consumption of y is same as denoted by A and B, consumption of x is falling from point B to point A. That is, consumption at point A of x is x3 and x3 is less than x2. x3 is less than x2. So this means, this proves the consumer cannot be indifferent between A and B. Correct? Now consider points C and D. Let this be x4, this be y3 and this be y4. The consumer is indifferent between M and C, and the consumer is indifferent between M and D. Correct? Because M is the common point between IC1 and IC2. So, considering points C and D, the consumer is indifferent. The consumer is indifferent between M and C. So M is, the satisfaction from M is identical to satisfaction from C. Again, the consumer is indifferent between M and D. So satisfaction from M is the same as satisfaction from D, and these two lead us to the consumer is indifferent between C and D. The consumer is indifferent between M and C, and the consumer is indifferent between M and D. So the consumer is indifferent between C and D. But is that actually happening? Is that true that the consumer is indifferent between C and D? Let us see. You see, point C denotes x4 of x and y3 of y. This is C. And D denotes x4 of x and y4 of y. That means point C denotes more consumption of y than D denotes, whereas consumption of x is same on C and on D. Therefore, the consumer cannot be indifferent between C and D, as C must be preferred to D, as C is denoting more of y while x of remains same as in D. So the consumer cannot be indifferent between C and D. So what we can conclude? What conclusion this explanation leads us to? The conclusion is two indifference curves cannot intersect each other. If two indifference curves intersect with each other, then the indifference curves become self-contradictory. Therefore, two ICs cannot intersect each other. Yeah. Yeah, that's it. So far so good. This is all about this video. I think you have understood this well. Still, should you have any doubt in your mind, if you have any particular query, please don't hesitate to let me know through the comment section. I shall be very happy to reply to all your relevant queries. If you think this video is beneficial for you, please do share the video with your friends, brothers, sisters and colleagues, so that they can also get benefit by watching this video. And finally, thank you very much for watching this video. Stay well and goodbye.